Hello. Welcome to physics. Today we are discussed about the projectile motions. Projectile motion is a most important part of the physics, and let us start one by one each topic of the projectile motions. Initially, we are discussed projectile motion in uniform electric field. Projectile motion in uniform electric field. Suppose that this is a charge plate, uniformly negative, can be uniformly positive. Both situations are possible. Suppose that negatively charged distributed as like this, and direction of electric field vertical downward as like this, and value of electric field vector E vertical downward, and charge particle, positively charged particles plus q charge particle projected in a uniform electric field as a given diagram as like this. In the situations, calculate flight of time of the charge balls and range, and also the height of projections of the charge ball. Find flight of time, second height of projection, of charge ball, and third range of charge ball. Like, and start solving this problem. Initially, we are divided component of the projectile velocity. Suppose that this is a projectile angle, and along this directions horizontal component of projectile velocity. Suppose that projectile velocity u, and along the horizontal directions u cos theta, and along the vertical directions u y equal to u sin theta. U y mean horizontal and vertical component of projectile velocity mean u x equal to u cos theta, and u y equal to u sin theta. This is a component of projectile velocity along the x and along the y direction. This is a x direction, and this is a y directions component of projectile velocity. For the flight of time, responsible vertical component of projectile velocity, and can be used the first equation of motion for this derivations from first equations of motion for the flight of time of the charge ball. Mean first equation v equal to u plus a t, and convert along the y directions v y equal to u y plus a y t, and a y mean g effective, and g effective, value of g effective equal to minus q e divided by m plus g, mean acceleration due to gravity. Suppose that this is a positive charge, and direction of the electric force due to electric field vertical downward, because this is a positive charge and electric field vertical downward act, mean q e divided by m is a acceleration due to electric field, and acceleration due to gravity also act vertical downward, mean both accelerations act vertical downward, and resultant acceleration mean g effective vertical downward, mean q e divided by m plus g is a g effective, mean value of g effective, and v y, value of v y equal to 0, and u y equal to u sin theta. All value put here, mean t equal to u sin theta divided by g effective, and t equal u sin theta, and value of g effective put here, mean QE divided by m plus g, and total flight of time t equal to t, mean time of ascent equal to time of descent equal to t, right, mean time of ascent as like this, mean time of ascent from this point to this point, and time of descent from B to C, right, and total flight of time t equal to u sin theta divided by g effective, mean value of g effective QE divided by m plus g, mean acceleration due to gravity. This is a concept of flight of time, and similar we can be calculate the value of horizontal range and height of projection, them similar height of projections. From third equation of motions, third equation of motion mean v square equal to u square plus 2 a s, right, mean convert along the y directions, v y square equal to u y square plus 2 a y h, mean h is a height of projections, and a y mean g effective, and value of g effective equal QE divided by m plus g according to given diagram, according to given situations, and Vy equal to 0 at peak point, vertical component of projectile velocity becomes equal to 0, and Uy from the initial explanations u sin theta, and all value put here, and value of g find u square sin square theta divided by 2 g effective, and value of g effective put here, h equal to u square sin square theta divided by 2 bracket QE divided by m plus g. This is a most important formula for the physics for the JEE Advanced exam related to uniform electric field when charge particle projected in a uniform electric field, and basic concept about the G effective calculations. And next problem related to this, horizontal range. What is the concept of horizontal range? Suppose that this is a charge plate uniformly negative according to given diagram, and charge particle projected at this point A plus q charge particle as like this. In the situations, the distance between A and B, right, this is a horizontal range R, and for the R responsible horizontal component of projectile velocity mean ux, right, mean horizontal range equal to horizontal component of projectile velocity multiply flight of time, and r equal to u cos theta multiply flight of time 2 u sin theta divided by g effective. G effective mean QE divided by m plus g. This is a value of g effective, mean r equal to u square sin 2 theta divided by g effective, mean QE divided by m plus g. This is a basic concept, basic explanations of the horizontal range of projectile motions, and can be calculate next problem related to this. Next PYQ problems. Question second. Suppose that this is a ball, and mass of the ball m, and projected with velocity v naught with angle theta from the vertical directions, and wind flow along this directions, along the negative x directions with accelerations a. In the situations can be calculate the flight of time, range, and height of projections according to given diagram, right. Find, this is a paper plane, find first point, flight of time, second height of projections, and third horizontal range. Of projection, right. Similar basic concept we can be calculate the same problem, flight of time, height of projection, and horizontal range of projections. Initially we are divide component of given projectile velocity using the concept, this is a horizontal component and this is a vertical component. Vertical component v cos theta and horizontal component v naught sin theta, because angle from the verticals. This is a horizontal and this is a vertical component. For the calculation of flight of time responsible vertical component of projectile velocity, and ay equal to negative g and vy equal to 0, uy equal to v naught cos theta according to given diagram, right. Using first equation of motions, v equal to u plus at and convert along the y directions, vy equal to uy plus ayt, right, and put value here. This is a 0 and this is a v naught cos theta, right, minus ay equal to negative g and t, and value of t equal to v naught cos theta divided by g, and total flight of time t equal to 2t and t equal to v naught cos theta divided by g. This is a basic formula of the flight of time of the projectile motions according to given situation, according to given diagrams. And next calculation for the height of projections. For the height of projections, from third equation of motion, mean v square equal to u square plus 2s, and convert along the y directions, vy square equal to uy square plus 2ayh, and all value put here, mean vy equal to 0, because at a peak point vertical component of the projectile velocity vy equal to 0, right, and uy equal to v naught cos theta, right, ay equal to negative g, and h equal to v naught square cos square theta divided by 2g. This is a value of horizontal maximum height of projections. This is a basic concept about this, and for the horizontal range of projection, right. Horizontal range of projections according to given situations as like this. This is a horizontal range, and for the horizontal range using second equation of motions, mean s equal to ut plus half at square, and put value here along the x directions, mean x equal to ux t plus 1 by 2 ax t square, and here ax equal to negative a, right, and ux equal to u v naught cos v naught, ux equal to v naught sin theta according to given diagram, because angle from the verticals and horizontal component of the projectile velocity v naught sin theta, V naught sin theta, right, V naught sin theta, and all value put here mean x equal to V naught sin theta multiply t minus 1 by 2 a t square, right. This is a horizontal range, this is a horizontal range of the projectile motion, and basic concept related to this and most important concept of the projectile motion when charge particle move in a uniform electric field as like this given situations.